Boo. Hey everybody. Yeah, I'm gonna continue on. This is just gonna be a really short stream today. I just wanted to give you an update on where I'm at with the pedal board. So I guess I'll show you what I got put together here. So last time we left off, I ended up modeling a couple things, some effects pedals and whatnot, and I've got well, I guess I'll show you this. Yeah, so I had modeled a couple of my pedals. I added a couple things too. I just wanted to make sure I had room for any power jacks that may or may not be plugged in straight into the pedals. Worst case scenario is they're like a straight style. The ones I have are actually like these angled guys. So it's straight on one end and then it's got a 90 on the other. But I just wanted to have this pedal board handle both scenarios, so that's what I got going on. So I ended up doing some test fits. So for example, I've got a 3D printed rail, and what I wanted to be able to do was like shove these into the frame and then have them bolt together. So I decided on a couple bolts. Specifically, I settled on some 1032 3/4 inch screws to like bolt the whole thing together. And I also went with the hex head on these. So there's a couple of reasons why. So first off, this is sort of a stand-in here for the frame, and I've got an example here of just a prototype that I threw together. I just wanted to test print it and see how everything would turn out. So this is also Rev 2 of that whole process, and I basically got hex heads embedded with those 1032 screws. So this middle section here kind of represents, here I'll move my mic, kind of represents an actual frame. So this would be like a 3D printed frame that would kind of be like in this orientation with the ground down here. So the idea is that these rails can like bolt through the whole thing. And I'll take this apart here too. So this way you have the ability to kind of link rails together. Now this is just a test print. Obviously these rails will be much longer in the real guy. And I went with hex head screws specifically because I went with 1032, but I also wanted to make sure that they took 4mm Allen key or 5/32. Technically that's what they take, but there's a nice overlap between those SAE and metric hex drivers that you can get away with that. So the reason why is because, you know, I figured I would be able to source some Allen keys. They're pretty cheap. So I could also toss that in with the kit as well. So the idea was I can have screws, and then there's also captive nuts inside the rails. So I can flip this out, and then you can see that the nut's right here. And I also settled on, well, it's a specific kit from McMaster-Carr. You get packs of these screws and nuts. So nuts come in packs of 100, screws come in packs of 50. So I figured I could use those, and that would be a cheap way to do things, because I hemmed and hawed about whether or not I was going to do heat set inserts inside these rails or not, but I kind of like what I came up with. So basically what I've got is I've got a rail, and it's, if you rotate it, it's got rotational symmetry. And then this is a stand-in for the actual frame of the pedal board. So the idea is you could have one frame here, and then you could add you would have a frame on either side, and those are basically going to be the supports that for when you push down on everything with your feet. But then if you want to add another group of pedals to the right or left of it, then you can kind of cascade them like this. So the idea is like you'd have a rail that's about, I don't know, 9.5 inches from center to center. So from this center to the secondary one, when you have this installed all the way, then it's going to also go all the way across to be about 9.5 inches. And the reason why is because if I take two Boss pedals with these extremely long cables. That's still enough room. See how these jut out from the side of this guy quite a bit? Well, this way I have the ability to cascade 2 of them, and then still fit it in the print bed volume that I'm dealing with. So the idea is you can put in a hex nut inside this little slot, and it sits there with pretty good tolerances actually. And then when it goes into the frame, it'll cover up that nut slot as well. But then you'll be able to see, like, in here it lines up. So that hex nut on camera, I can see it there, right? So what's nice is if this is on the end of your pedal board, then you can just put a screw right there, and then just use an Allen key to screw it in. And also, I'm probably going to incorporate storage for whatever Allen key I manage to find cheap in bulk, because you don't need an incredibly good one, you just need one. So right now you can see that rail is secured in the frame like this, but if you wanted to daisy chain rails together, you can just undo the screw, and then you can take another rail and shove it in, but you just want to have a nut in there as well. So we've got that going on, and so now I'm able to put a bolt through this way, and that'll go through the whole housing in through the other side because they're angled. So that's just one, and that's pretty secure. That crack was my knuckle, not this thing. So with just one bolt, it's perfectly fine. So that's another thing is I know that these are strong enough. Because initially I looked at using maybe smaller screws, but then I had more of them, and then I figured it'd be like more of a hassle to assemble everything as well, for both me and any users. So, but if you want added strength, you can put a second one in this way as well. And that thing is not coming apart. So the main thing I would want to worry about with this setup is it cracking along the layer lines of this frame. But this is bolted into this, and this is bolted into this. So it kind of helps with worrying about the strength of the frame as well. And because of the way that this is printed, it's actually in the strongest orientation possible. Another thing I added was, so initially I had a rounded hole, kind of like this. Now you're going to run into, this was just to quickly test to see if it was going to be strong enough. But when you 3D print something, so this was printed flat like this on the bed. You can see the nice glossy side was touching the bed. And so now you're going to get overhang here. So all I did was I just expanded that to, I think it's like about a 75 degree angle, like between the two edges of this, so that it's symmetric. But it's handling the overhangs just fine that way. And then I can still print it in its nice strong orientation. So this is basically what I had to come up with, and it was just kind of tricky to do on stream because you need to be able to like trial and error a few things, and I figured without really going in with a plan, it wouldn't make for good content. So that's basically what I've got. And so if I switch back over, this is sort of like my starting point here. So what I've done is I put in an assembly of, if you want, you can also embed a nut into the side of the frame here. So with the end open like this, these are just stand-ins for the actual or what do I call them? Frame. Yeah, it's a frame part. So I'm probably going to end up starting with this frame piece and then duplicating it, and then I'm just going to join that geometry together, so that I've got a bolt together frame. So what I have here is I've got two rails. The newest rail has a cutout, sort of like a little trough for the Velcro to sit in. Now this would be that means that this would have to be the top side of the 3D print orientation when I make this part. So this side would be on the bed, and then just so gravity's working with you, the nuts, which are embedded in here, are I have them so that they're not too tight. I want them to be loose enough so that you can easily get the nuts out and repurpose them if you need to. But like when I provide a kit, I'm going to have enough nuts so that you could bolt on another section, and you can just have this nut be here, but it's also held captive by this frame piece here. So, but yeah, there's a recess for Velcro, and then the Velcro itself would just stick to that. And so I've got some 3M Velcro here. Is that gonna reload? Did it die? Interesting. Alright, well, I lost my caliper cam. But yeah, so what we'll do is I've roughly positioned things too. I've made just a little quick, dirty assembly with some of my effects pedals. So I've got the Boss pedal that I had modeled last stream, and then some of these patch cords here. I might as well just like show all of my instances here. So yeah, what I did was I had this here so that I could roughly position things. So if I take like this little pedal and just kind of put it here, you can I want the rails to be spaced so that the small pedal and the Boss pedal are just as happy in terms of like how far things have to straddle. And then because it's open like this, it allows us to route cables under or through these sections of the actual pedal board. And then this is roughly positioned, like I've got this just planar. So these extra guys are planar with this, but I just wanted a rough idea because this is why I modeled all this other stuff that's not the pedal board, just so it's easy to kind of fit things together so you can visualize it beforehand. So I like the spacing. The spacing I got center to center between here, well, the distance from here to here is 3 inches. So that seems like a pretty good spacing. And then the other thing that I need to consider is I want to be able to have room under the pedal board for a power supply. Now the one that I've got is it's actually pretty chonky. And a lot of pedal board power supplies that you'll see, they'll be actually a little less tall than this. Maybe so. If this thing can fit, then most other ones should be able to fit. The other thing is I'm not totally sure about what's the best way to mount this thing to these rails. So I'm thinking that maybe we can go ahead and route out some channels here on the bottom of this guy. Because what I want to do, let's see if this caliper cam's still busted. Yeah, it might be. Let me take a quick second here to take a look at this. Properties. Let's see if this will refresh. No, it's dead. Yeah. Okay. Well, so basically I've got this Velcro, which doesn't have adhesive on either side. So this would be good for cable management. So what I'm thinking is I can take, say, the frame of one of these frame pieces, and I want to do some channels to route that Velcro through. That Velcro might also be able to serve as a way to mount other power supplies underneath the actual underneath this section here that goes across between the two frames. So one thing I want to do on this stream is at least, well, we can modify some of these rails. And one other thing too is it doesn't necessarily have to, I want to channel in these rails for the Velcro to pass through. But I also want to have some that are also dedicated to tie wrap slots. Because maybe you want to tie wrap all the power because it's essentially going to be routed the same way forever. If you want to take the pedals in or out, I just figured I'd give you a more slightly permanent option, because the thing is I'm not going to include a set of side cutters with this thing. You get an Allen key with the hardware and all the parts that you need to bolt things together. But then when it comes to like doing all the cable management, I just wanted to visualize roughly like where our cable is going to be in the grand scheme of things. And so I want to position any features that are going to be on the underside of this, or potentially on the side of this as well. Because I want this piece to be repeated, so I only have to print one kind of part. And then I can make it so that you just reuse that same part over and over again. But then I want to make sure that wherever this stuff is final position, wherever the final position of all these objects is, it makes sense to have those features on the bottom of the thing. So, and then, yeah, the other thing I want to do is also just get the frame itself, instead of these little stand-in inserts that are here. This feature is sort of something that's going to come, that's going to go with the frame, but I'm just going to pattern it to achieve something like this spacing. But ultimately, you can imagine this and this and this and this, these four parts as all one body that sort of has an extension that goes down just slightly, just so that you can route cables underneath it. I mean, I have like a core, it's about I think it's, yeah, 0.2 inches. Which is just about enough to get a patch cord, but if you ran it underneath that, it might get squashed. So I'm toying with the idea of some kind of rubber feet. So the frame piece, I want to at least get the design started for that, and then get some tie wrap channels in these parts here. So I guess we can. What should we start with? I guess we'll get the cable management features in the rail added. So so what I've got here is I've got another part studio. Essentially, I wasn't totally sure that all this was going to work, so I just sort of made like a temporary part studio. But this essentially will be my starting point for any rails going forward, because really what I had to figure out was how is all this going to bolt together. And then now that I've got that, I can actually start designing the final rail and what it'll look like. So what we'll do is, I've got a part studio made here. I've just pre-named things, but I'm just gonna use this derived feature. By the way, I'm using Onshape here, so it's free for makers. So I have a commercial license because I need it for my company as well. So I have the ability to have private documents. If you go and sign up for Onshape with the free account, then all of your documents are public, which may or may not be what you want, but it's a great browser-based CAD program. So if you're curious what I'm using here. So I'm going to start off with this rail. And what I'm going to do is I'm just going to reposition this rail so that it's centroid here on the bottom is coincident with the origin. So what I'm going to do is I'm going to perform a transform. I'm going to move this entity, and then you can transform by mate connectors. So I'll click on this mate connector and then mate it to the origin. It ended up flipping it, so I'm going to flip its orientation, and then that's where we're at. Okay, so now I've got that guy positioned where I want it. So back to this like test fit pedal board thing that I had come up with. So basically, we're gonna have cables that are plugged into our pedals here in between things. And then remember, this is the input and this is an output. And then these two might be part of the same cable. So you could imagine it dipping down like that and then going over to the next guy. So maybe we want to have something where we have a piece of Velcro in the middle so that you could, let's say this was like a U-shaped loop. It could at least be held securely this way. The other thing is the power that's coming out of these pedals. We'll probably want an ability to cable manage that connection as well. So my guess is that if I were to split the difference and go with this rail, if I want to put some cable management features in here, at least on the bottom, we can do that in the middle, and then about a third, half of that distance here, and then half that distance here, something like that, so that we'd have 3 features. So what I'll do is, what's the best way to do this? So because I've got this centered, or I've had that face on the origin, right? I'm actually able to leverage a couple things. So what I think I'll do is I'm going to start by sketching on the top plane. And then so I want to take a look-see at my Velcro, which basically I've got a big old roll or spool of it. So this is I forget how many feet it actually is. Didn't even say. Yeah, 13.7 meters of it. So I'm not running out of Velcro anytime soon. But the other kind of Velcro that I ended up grabbing was 1 inch with the adhesive back. So that's the stuff that's going to go here. But the other stuff is that loose stuff. And that's about, well, let's find out. Because I can go with the nominal measurement, but yeah, so it's like interesting. So yeah, because I remember this was 3/4 inch, I think, 0.75 inches, but it's actually 0.77 right now. Yeah, so I want to make sure I've got wiggle room in 3D print for that as well. So what I'm going to do is I'm going to sketch on this guy. Now, what I'm envisioning is we've got like an arc-shaped cutout in here. And, you know, yeah. So what I'll do is I'll make a rectangle. So I'll make this one a center point rectangle, and I'm just going to put it along the center here. So the center point of it is this guy. I'm going to make a variable, and we're going to call this Velcro strap width. So this is, let's get 0.78, let's say, inches. Okay, so that is going to be the width of the guy, and then roughly, how thick is this thing? I'm not going to be squishing this. 0.07, let's go 0.08. All right, so now we've got a little channel here, and so you can imagine that what I'm picturing is a really big circle like this that's outside here. And then what I want to do is I want to do what they call a sweep. So what that'll do is it'll take the path of this guy and I want to sweep cut it through the body here. So to do that, I need to have it somewhat far away, but I don't want it so far that I've got like zero wall here. So I'm going to go with a yeah, 1/10 of an inch would be perfectly fine there. So we've got this. Now to do the other guys, I'll also just create some more rectangles that are the same size as this. Okay, so I'm gonna click on these 3 lines and hit E to make them all equal. And then, oops, I'm gonna click on these lines here and make those oops. So I've got a constraint here. So one thing is you can click show constraints. So for now, I want to see why that broke. Right off the bat. Oh, okay, so that is constrained here already. That's already constrained. So I don't need to make them equal. It's because I've made this horizontal. And then I've made... Where is that? So this guy here... Yeah, so when I drew this guy was told to be collinear with this, and this guy was told to be collinear with that and this. So what's happening is it's the same, so I don't have to dimension it. The only thing that's not constraining where these are horizontally is an offset distance. So right off the bat, let me take a look at our pedal board here. So we've got... Yeah. What I want to do is I want to see roughly where the face of that is. You know what? I'll do it in reference to this. So I'm going to click on that guy. And then I guess I'll click on this edge here. So I'm going to switch to my desktop cam so that you can see in the bottom here there's a measurement selection. So I'm basically looking from that face to this circle, and you can look at center distance. So about 1.7 inches, let's say, in the X direction. So knowing that, I'm just gonna like set that offset on this guy. So switch back to this. So what I can do is I can project this down. I'll project that, and then I'll project okay. So now what I'm going to do is I'll just distance this. So the other thing is those power cables are coming straight out of that thing, which this isn't necessarily even helping to solve that issue. So I might actually make it a little less than that 1.7 that I measured. But I don't want it. What I don't want is it to interfere with the frame. Like I don't want this to be in behind it whatsoever. But I know that if I'm any distance from this, I'm not running the risk of having that happen. So what I think I'm going to do, actually, I will get rid of, I'm going to get rid of this and I'll dimension this center point. So that would be basically bang on or pretty close to it, but I might want to have another feature that goes the other way to give you more than one way to cable manage things. So you can cable manage in different directions, basically. So I'm going to go with 1 point. Actually, let's just go with 1 inch. So that's not too bad. And I don't think that, let me just click on this and I'll project this guy down here too. So yeah, okay. So even then I'm still not like involved with any of these features here. Yeah, so I like that. So let's like make that 1 inch there, and then we'll do the same thing with this guy. Okay, so now we've got basically the faces that we're going to be like cutting out from the bottom of this guy. So we'll call that sketch done, and then the next thing we want to look at. Yeah, so I'm going to sketch on this plane here. And then what I want to do is, so now with that other sketch visible, I've got entities here that I can grab. So what I'll do, this is what I'm thinking at least. So I've got a center point circle. I want the center of that circle to be here. And then I want to put this guy something like that. And then what I'll do is I'll project this as a line there. So now I can kind of play with how steep I want this circle to be. Because I want you to be able to easily put the Velcro through, and then if there's any resistance, I don't want it to be too hard to push through. I don't want it to be like playing pool with a rope or something. So I want some amount of an arc, and the more severe the arc, the stronger the connection actually will be, because there'll be more layers. Because remember, this is going to be printing in this orientation with the bed here, and then it's printing layer by layer all the way up to the top. So let's see. Something like that. Let's see what this distance, or what this diameter is. Okay. Let's try 1.6 inches. I think that would probably be okay. Yeah, and again, it's nice to 3D print this stuff, because you can just tweak it. Keep tweaking and tweaking. But roughly that's like, looks good to me. So we're going to go with that. And now the other thing that I'd like to do is just do, they call it a 3-point arc, I think. Yeah, where is it? Not tangent, 3-point arc. There we go. So I want this one and the intersection between those two. And then I can set that. Now it'll ask me to set the radius. I'm just going to make that point coincident with it. So now I've got this construction line, which is the circle, but then the actual path that I'll be traveling across, or cutting this rectangle out from, is going to be that path there. So we'll call that. So now what I'll do is, so we're going to use the sweep tool, and we're going to remove, so the sketch faces and sketch regions to sweep. So that's going to be this rectangle, this rectangle, and this rectangle. And then the path that we're going to sweep along is going to be this path. So you can see, oh, and then there's one other thing too. Profile control. Profile orientation? No. There's a way to... Oh, I thought you could keep this normal. They might have changed the feature script a little bit. Lock profile faces. Does that look right? No, that does not look right, does it? Okay, so let's try this for a second, and then I can always go back and edit this feature. So yeah, you can see, like, ideally I want this to go all the way through like that, but I wanted to follow that path. But now what I'm dealing with is it's changing its orientation as it cuts through the part, which is pretty frustrating. So I'm going to take a look-see. You know what? You know what's good for this is we can do a section view. So we can go section view. Okay. So you can see here, it wanted to keep. Oh, that's interesting. That's really interesting. Okay. So what's going on is it actually kept sort of the profile I wanted, but it ended here because the end point of my line was at this point here. But I think I'm gonna have to actually continue it on a little bit longer. So let's go back, and we'll go back into Sketch 2. And then what I'll do is I will extend that arc. Something like that. And then I can take this guy and make that coincident. So this way it'll go all the way through. Now let's try that. So so what I'll do is go back to the sweep feature, and then the sweep path is going to be, there we go. Okay, that's better. Now the thing is the overall height of this thing is maybe not where I want it. So I want to see if I can go keep profile orientation. What is that going to do? Oh, it doesn't like that, does it? What doesn't it like about that? Lock profile direction. Yeah, they've updated this feature. Okay. Yeah, I think I'll go with that. I'll go with that guy for now. Another thing you could do is you could also make the circle just be the diameter of a circle that had its center point about this, like say the origin, for example. And then you could just do a revolve. And I've done that for tie wrap features before, but yeah, this seems like a little more wide open now, so this seems to be what I'm looking for. So ultimately I can still do a section view just to sort of inspect things. So let's see, section view, and we'll do it about this. So now what I can do is I can click on, oops. So there's my section view, and then I can click on that face and that face. Minimum distance 0.038 inches. So that is about half of what I want. Because you can see, like, I made that rectangle this width here. So I can actually just like tweak that a little bit just to make that come out a little better. So I'm going to go back to Sketch 1, and that dimension that I had done, I'm actually going to rename, I'm going to make it a new variable. Velcro strap thickness. Let's call strap, let's say cutout. Okay. So, and I'm going to delete this one because I'm not using it anymore. So now let's take a look. And then show my measurement. So the minimum measurement is 0.047. Okay. So I'm going to have to make that bigger. It's possible that I can look into the actual profile orientation, because you used to be able to click keep profile orientation. It would keep it normal to the thing, and then it would just pull that along the path, which it almost seems like it's trying to do, but yeah, kind of annoying. So the other thing I can do is just like move this face down if I want. But ultimately I want to try just seeing what this feels like, because I do want a little bit of resistance anyway, but I want enough so that it can shove through, because really the Velcro, I'm taking a nominal measurement, but that's this, and that's 0.082, but if I check it like 0.0565, 0.05 is basically the max that I could feel like I could shove through that hole. So I mean, I can quickly change the cutout thickness, but there's a better way to be doing this, so I might revisit it. But it's just like on stream I could figure it out, but yeah, that's still doing that same profile. I feel like it's not really making a huge difference here. So what I could do also is make my let's just double check this here. Okay, measurement is 0. Okay, that would definitely fit. This might be all right actually, but again, what kind of thickness am I looking at here? So there. Okay, so I want to see what its distance is. 0.11. It's not great. Not great. So yeah, what I could do, I got another idea. Okay, so instead of a sweep, let's ditch the sweep, and then I'm going to make a plane here, and then I'm going to do a revolve, and then I'm going to cut it out that way. Because the issue here is, right, we've got this face here. I was thinking, okay, well, I want that to be like where that hole starts, but really I should be starting it up here, and then I could rotate the whole thing around, and it would be normal to the face of that. So I more or less have like the arc I want already. So instead of dealing with that sketch, what I can do is I can make another plane. We can make it, where's the the top plane, and then the plane point is going to be this. So now I've made another plane that's like just offset from the top plane, but it's the center point of our circle is on it. So what I'll do is I will sketch on this plane. And I can still make this Velcro strap cutout thickness. And then I can make this Velcro strap width. Make that coincident there. And then I can project that. And I will put this guy here. There we go. Okay, what is the distance between these two? 3.1 inches. Let's just use that. And then, yeah, we'll do another center point rectangle. So equal, and then this one, we'll make this one equal as well. Okay, so now I'm going to take and I'll make this one the same. Okay, so now we've got that done. All right, so now I'm going to do a revolve. I'm going to do a revolve from here and here and here. And we're going to remove, and the revolve axis is going to be this. What in the fuck? Those are them. The axis I want. Okay, cool. That's better. So now what I can do is actually just make the cutout thickness be exactly what I want that rectangle to be, which again is going to be this basic nominal thickness of the Velcro. So I'm going to make that, well, I'll make it a bit snug. 0.08 should be fine. Yeah. Okay, so now we can see that that is 0.08 the whole way. Yeah, that's better. So I'm going to get rid of that section view here. So now we've got that, and I'm going to hide these two sketches. I might as well hide that plane while I'm at it. So we've got something more akin to actually getting the Velcro where I want it. So we've got that now, and then another thing we can do is we can do in between the two. So we would have 3 straps going this way. That will be good for like cable managing things on its way over to here. But if I want to loop through, let's say I bolt on another section to this, I might also want to do something, at least maybe one like here and here on those faces. That would be pretty good to have, I think. And then I would probably just end up putting them on both sides to make it mirrored. so that you can't really put it together wrong. Because really, you can rotate them 180 degrees either way. You put rails together, and they'll still fit. I think. Well, maybe if I make the frames asymmetric, that's not going to be true. But yeah. But yeah, so I've got those features here. Maybe I want to put 2 of those on the sides here, and I can't see me doing this any differently. So one thing I'm going to actually double check here. I want to set the radius of that circle, that great circle that was used to cut this out. I want to actually set that as a variable. So I don't even remember how many. It was like 1.6 maybe. And actually, I think that was the diameter, so I'm just going to call it diameter. There. Okay, so if I take this guy, bring him back, and then I go with my circle sketch. Yeah, it was 1.6. Velcro circle diameter. Because I want to use the same radius. And then if I find that it doesn't really work all that well, I can change that, right? So, but I just change that one variable and then I get it all for free. So what I'll do is I'll do the same kind of thing, but I'm going to sketch on the right plane. Scooch. Okay, so I'm going to take those 2 and project them. And then I'm going to make that. Because what I want to do is I want to make sure that this circle okay. So now, yeah, the slightly tricky part is that I'm gonna have to make, by the way that I've got this going, what's the best way to do that? Because I had an offset distance from this face. Oh, also, this is also a different different thickness. It's actually wider in this direction than it is this way. Part of that is because I wanted to not have to use more than these fasteners, and then also I wanted to have some strength from bending, which is why it's as thick as it is, because you're going to be pushing your foot down on it. But I think I'm going to need to change what that offset distance is. So I think actually the best way to do this is do an intersection point here, an intersection point here. And then I can measure this. Because that 0.1 was what I did on the other guy. Yeah. 0.1 from him. But That's going to leave even less material in there. But also, it needs to be like reasonably tight, because when you're like, the cables aren't super wide, so like this distance is actually quite a bit. I might make this a different variable. Velcro circle diameter. Variable. Yeah, I just wanted to dip in a little more. And the tricky bit about this is this one would be along the layer lines. So that means that your bottom guy is going to have an overhang when you go to print it. It's going to have to bridge across it. Which it's like a quarter or 3/4 of an inch ish, which is not too much to bridge against, but it's something to think about. So, yeah, I can try this. And again, I can try this on a test piece as well, just to see how that all fits. But yeah, this should be okay for now. But yeah, because as long as I get those features in, then I can just tweak whatever the values are that I'm going to need to be kosher. Because overnight, I'll just print a couple of test pieces with these geometries. It'll be like little slices of this. I'll save you from that. But yeah, so we'll go and try doing that. Because this is essentially going to be our revolve axis. So we'll go with that. And then, so I'm going to need to also do a sketch on a plane that's like here. Right? Or I could do a 180 revolve. That would be fun too. So, yeah, let's take a look. Let's just do a plane. Mike McPhee sending us messages on the jam chat. Alright. So, yeah, and I think what I'll do is I'll just take this and this. I just want this to be like halfway. So I'll project those onto my sketch here. And then I can do a little construction line, y'all. A little construction line, y'all. And then one of these. And then one of midpoint. There we go. One of these. That coincident. And then I will check that. Doesn't have to be perfect. So I'll make this coincident. And that also coincident. And this is going to be Velcro strap width, and then this is going to be Velcro cutout thickness. Okay. Okay, cool. And then we will revolve, remove. Revolve axis is going to be this circle right here. Okay. There. Okay, and then what I'll do is I will just mirror that feature. So there's a way to, you can do mirror, and then you can do feature mirror. Features that I want to mirror is this revolve, and then the mirror plane is going to be the front plane here. So yeah, we've got something like that. Cool. So now we've got Velcro mounting points on the top, on the sides, on the bottom. That's pretty decent. And the other thing I can do is I could do a similar sort of feature with tie wrap channels, but I actually haven't decided on a tie wrap to go with, because I want a tie wrap with predictable dimensions, and then we can go with that. But I won't source those immediately on stream or anything. I gotta look at the price, and you don't want to see me looking up a bunch of prices maybe. But yeah, so basically these features will let us take Velcro and shove it through here, and then we can cable manage on this face and on this face down here. And then if you have that on every single rail, that's sick. The other thing, so for considerations that we need to make for, say, 3D printing, the only other thing I would consider doing here is, you see this, printing that vertically, not great. I would want to make at least whatever my layer line thickness is. I would want to make sure that the thickness of this guy here, of this little feature, is at least, I'm probably going to end up doing 4 parameters on the final thing when I go to sell it. So I'd want to at least what 4 parameters would be. Let's say I'm 0.4 millimeter nozzle, it would be 4 times that. So, because if you do just a single line across, that's going to be weak. And then this way I could at least have, 4 perimeters going across, and then that would be as thick as it needs to be to start. So the only other thing I would want to do here is just, in fact, I might as well do it right now. Let's just sketch on this. And now this is sort of tricky to do. You're doing the inner, it's giving me like Calculus 2 vibes. I couldn't do that right now if I tried, but when we did Calculus 2, doing like intersections of, or well, I guess it would be a vector calculus sort of thing back in engineering school. Trying to find the intersection of this where this chordal distance from here to here is a given thickness, but I can just measure it after the fact. So I'll set this to be let's see. Overhang. Cutout. Length. Okay. And then I'm going to do this similar guy here. So that's going to be there, and guy. Because I might as well make it symmetric. I mean, I know the printing orientation already because I had this recess, but Might as well just make it symmetric. And then it will be strong up here too. This won't be nearly as weak with one perimeter across it, but why risk it? Just make it more skookum. So this and this are equal. Okay, now I'm gonna extrude. I'm just gonna cut this, remove, and up to face. This face. Yeah. So this here, 0.0179 inches. So sure. So 1.6 millimeters would be 4 perimeters. 0.06. Yeah, that's not nearly enough. Okay. Cool. So this is why I'm doing this. So we can make that 0.2. .03. Yeah, because this is what they call CAD goggles. All right. So that looks fine and big to me because everything's nice and crisp. In reality, that is what I need is that. Okay? And what I'm measuring on here is half of that. So this is what CAD goggles will do to a man. Okay. Alright. So, alright then. Let's take a little, oops. Let's mod that little overhang cutout length there in 0.25, eh? Oh, frig. Okay, so here we go. Nope, not very much. So actually, in fact, this might not even be enough. There might not even be enough wall thickness for that. So if that's the case, then what we're gonna have to change is lesser circle diameter. Let's just make that 1. What does that look like? Okay, so that seems thicker. There we go. So what that did too, right? Like now we're dealing with that kind of a circle, but we're dealing with that circle and what's the best way to highlight that for you so you can see without doing a section view? I don't know that I can. Okay. Section view. So now we've got like a decent tab, but it's curved. So you can push it in along this whole edge and it'll come out the other side. And then it's like decently thick. And then that's happening on both sides. And then if we go and we head back into here, we've got that. So on the bottom, I might as well change the other circle too. It truly can't hurt. Now with this, I can probably also do the same kind of cutout so that we have that sort of sawed off circle shape, which is better in my opinion. And then you get to go straight up in layers. Because yeah, if you want to like wrench on the edge of something, it just seems like the Velcro is gonna rip through it. So so let's try that actually. So I will do a similar sort of thing here. So sketch, and we'll do it on this lip, same lip. Oop. If only I had like a real life fast forward button, I would do that for you guys right about now. So yeah, let's go this and this. So I had double the rectangles, or I had 2 more rectangles to draw than the last one. These are equal, and I will dimension this, and this one, oops. I will dimension this, there we go. What was it? Velcro, overhang cutout length. Extrude. Remove. Up to face. What face? This face. Go. Cool. Alright, so now we've got Velcro strap guys down here. I'm probably going to end up changing that that circle diameter too. Let's try 1 point. Try that. Yeah, that's fine. So yeah, now we've got a better look at this. So that's what we're dealing with. I'm happier with that, I think. So the only other thing is now when we print like this, okay, we're gonna have to be going and bridging from here over. I don't think that's gonna be much of an issue because we're doing it layer by layer. So in the same way that like I often 3D print holes and you'll see things like kind of collapse on themselves a little bit. So I wish that camera thing was working again, but it's busted. No, I can't show you that. So in general, when you have a hole shape and you print on the side of something, it's gonna sag on the top when it does the overhang. But the amount that it sags by is really not that much. And in general, it doesn't like completely separate. Because what I don't want is if it's so severe that you get the layers like coming down and then it gums up that channel. That's something I have to clean up, and I don't want to have to clean up anything. I want it to just come out perfectly. So that should probably do the trick. Yeah. So we got friggin' Velcro straps all over this thing. This thing's pretty baller. The only other thing would be maybe tie wrap straps. So again, I'm gonna have to source some, but I'd really like to print this out right now as a test piece anyway. Because I want to get a really good feel for how strong everything's gonna be, and then in practicality of because when it closes up, it's at least this distance, right? So if you got a little tiny thin cable and only one of them, it might not be that good. That's where we get into tie wraps if you really need it for one little tiny cable, but I'd rather it's the same amount. Like as far as print time is concerned, like it's really not that bad. Oh, one other thing I gotta do is mirror that feature on there. So mirror on the wall. Who has better Velcro strap holes? It'd be this guy, wouldn't it? Let's gonna go with feature mirror. Features to mirror. Believe that is it. Mirror plane is this. Reapply features? Whoa. Oh, okay. I know what happened. So I'm going to actually have to do this one separately because the end condition of that extrude was this face. So yeah, it's not going to like that. So anyway, I basically just have to do one quick sketch here and then I'm done. But yeah, so what I'll end up doing is just slicing this guy, and I'll let that one print overnight on one of the printers. I've got a lot of other orders right now with so I can't use a whole bunch of my printers to just bang out a whole set of these, but I can do one on one of them, and that should do the trick. But yeah, so that's how you add Velcro tie channels to something. In general, I've done this a lot before with tie wraps specifically. In a lot of the 45 drive server products, there's certain spots where you want to do some cable management in a semi-permanent fashion. So I've used this kind of feature in 3D prints all the time. It's actually been pretty ubiquitous in 3D printing for quite some time. You can even use it to like join faces together and stuff like that. You just put the same channels in one part and then another part, and then you cinch them together. It's pretty sick. But it's one of those things that's super hard to injection mold, because like the tooling that you would have to have for that is ridiculous. So I'm going to lean in hard to the 3D printing aspect of this pedal board, because that's what I'm building. So we can go with that. So this one's going to be, what is it? Overhang cutout length. Does that look right to you? Okay, something's wonky here. So it might have been, oh yeah, because I did another circle. So anyway, I can clean this up off stream. Basically just gonna make the other side look just like this one. So that's it. But yeah, so what I'll do is I'll print these out and we'll see. I'll get some Velcro on it. I'll probably print it in red just so we got like a good contrast. And then we can like throw some Velcro in it and just see how that works. So I plan on streaming tomorrow during the day, because I've got some things I have to take care of tomorrow. So probably like early afternoon stream is my guess. Unless my colleague needs to get lunch with me tomorrow. We'll find out. Anyway, thanks for tuning in. If you have any other ideas that or things you might want to see incorporated into this pedal board, I'm all ears. Or anything that I neglected, or just things that I can think about going forward when I go to do the frame. So I'm going to basically have a pretty much a finished rail by tomorrow. And then I'll get started on doing the actual frame design. And then, yeah. Then we can finally bolt this friggin' thing together and get prototype 1 built. And then I can find out what I hate about putting it together and all that fun stuff. So that should be a little more entertaining stream. And then I basically I'll actually have the camera working. I think part of the problem was the battery on the phone died because the phone was unplugged for so long. And yeah, it's charging off of a USB port on the computer, which is probably not enough to handle constantly streaming HD video on the wireless network. So yeah, we'll have a Caliber cam next stream. We'll build some stuff. Anyway, that's all I got for now. Thanks for tuning in. Take care.